This was life on the surface of the sea, a calm, placid exterior that could soothe you into submission or swell up and kill you with no notice. Beneath it, always a dangerous world of life and death. Keith Edaid said that in a book called Unwanted. And I agree, and that is why I want to explore the ocean. And I am going to do it with the power of STEM. Science, technology, engineering, and mathematics. I think this is the method that I will use to explore the ocean and experience its peace and never have to understand its death.
The question is, what is an ROV? An ROV is a remotely operated underwater vehicle that is remotely operated from the surface because it is underground. ROVs are often used in areas where humans cannot access it, in waters that are dangerous or in tasks that could possibly injure the human being. They often carry sensors or tools to complete tasks or cameras to observe and understand an environment.
ROVs have four major systems: onboard system control, external system control, communications, and mechanics. The onboard system control unit is responsible for taking the information from the communication system and relaying it to the mechanics system. In addition, it takes information from the mechanics system and relays it to the communication system. The external control system is responsible for relaying the information from the communication systems in a way that is understandable to the user, and then relaying the instructions that the user gives it back to the communication system. The communication system is responsible for relaying information back and forth from the external control system and the internal control system in a low latency effective method. The mechanics system is all moving parts and electrical components that do not think for themselves. Motors and ballasts and sensors that relay information or do as they're told from the internal control system. These three systems are made up of computers and software. They are mainly responsible for communications and processing. They are more in the software development and electrical engineering department, designing custom PCBs, programming microcontrollers and software that can interact between the microcontrollers and software on computers. There is very little to explain about these things. It's pretty intuitive. Collect information, put it in a format that can be transferred, transfer the information, process the information, relay the information, both ways. Very explanatory, and there's not much interesting parts of it. The mechanics system makes up the majority of the ROV. The beginning of it is the frame. This is the part of the ROV that everything else is attached to. The next aspect is the onboard computer, which the internal control system uses. This is followed by the communication hardware. One of the more important components on an ROV is the propulsion, the ability to move forward, left, right, up, down, and move within a 360-degree plane. To support this, you have ballast system, which helps you maintain a stable altitude in the water. The more technical part of this system is the sensors. Cameras, temperature sensors, proximity sensors, and water pressure sensors and water sensors that all relay information back to the onboard control system, then that gets relayed off to the external control system. One of the more important aspects is the camera system that relays visual feedback to the user of the submarine. Often ROVs will have a recovery system or a failsafe, as if an error occurs, you do not want your submarine stuck at the ocean floor. Finally, accessories, places to put modifications or other pieces of equipment that are otherwise unplanned for. And that is ROVs explained from start to finish and the basic construction of an ROV. Thank you very much for watching. Please leave a like, subscribe for more content, and we'll see you in the next video.